So, hi, is this started?
No, we are just admitting the participants. It will take a moment.
Thank you.
Sir, you can start now. 41 participants are there.
Great.
Let's
Okay.
start. I'm starting the recording. Okay?
Okay. Thank you, Param.
Okay. Yeah.
So good evening to everyone. I'm Dr. Akash. I'm working as assistant professor and the lead for Admire Center at IIHMR Bangalore. And we would be hosting this webinar. Mr. Vinay would be going through his entire setup of Gen AI and how to use large language models and other things to help you in working around with the data analytics part. I just want to have briefly talk about IHMR and then maybe I don't take more than 2 minutes and then we can start hand over to Vinay. The idea about this was that we have been long working in healthcare and we have been long working also on AI. So there were two technically separate things for traditionally with the way healthcare guys used to look for data analytics. We had our spaces where our data with all our softwares coming in, but now what we are able to understand the industry trends is that it's now much more easier and much more software independent environment. So this webinar specifically is targeted for the healthcare guys who want to utilize the power or the computing ease of AI it's basically using your the knowledge of how to understand the data and statistics part and making the AI do the heavy lifting for you. That's how we are trying to work around it. We also run a master's program called as PGDM for AI and data science in healthcare. The same idea is that we are trying to empower the healthcare guys to take a leadership position in AI field when it concerns to healthcare. We don't want people to change and start coding there, but instead of computer guys coming and leading the entire segment, the healthcare guys should understand what AI means. It should not be a black box for them, and should also try to kind of lead it from the healthcare perspective to make a more meaningful impact. That's how we are trying to work around with this. I think we have a small campus tour about IHMR Bangalore. Poonam, can we just go through that?
Yes, sir.
Should I stop share?
Yeah, you can stop.
Is my screen visible?
Yeah.
Could you put it in HD, please, if possible?
It's an edge. There are some issues in terms of the buffering time. you, Poonam. So yeah, we have a campus in Electronic City, Bangalore. Anyone, if by chance you're in Bangalore, you can drop by. We are the one of the few institutes in healthcare who have our own GPUs and own servers. We have a lab that runs for AI, and we have been building products on those. Our students have been building products on various things like oral cancer, breast cancer, lung diseases, and other things. So anyone is interested, you can also come in and just check it for a few times. Coming back to the seminar, we have Mr. Vinay Srihari. He has completed his master's in AI and data science from Ramaya University of Applied Sciences, and he has worked with Government of Karnataka for 2 years as a data scientist, and he has worked on the Sustainable Development Goals, worked on building predictive models for supply chain management. He is working as an assistant professor and lead data scientist for IIHMR Bangalore. And over to you, Vinay.
Yeah, thank you, sir. So, good evening, everyone. So, I'm working as assistant professor at IIHMR. I welcome you all to the session on prompt engineering strategies for multimodal analytics in healthcare. So, coming to the first topic in this webinar, which I'm trying to introduce, what is healthcare analytics? So, healthcare analytics involves systematic application of data as well as computational methods. It might be statistical methods or machine learning methods or AI methods to assess, monitor, and improve how healthcare services are delivered. It might be patient care or other services which are there, and how operations are managed in healthcare, as well as how it impacts the patient outcome. So, this is the definition of what is healthcare analytics. So, why is healthcare analytics important? So, it enables us for taking data-driven decisions in order to improve. It might be patient outcomes wherein satisfaction of patients can be improved, or it can be in terms of reducing costs which are involved, or if we have to increase the efficiency of our operations, we'll be able to use our analytics, as well as in case of optimizing our resources. So coming to the various techniques which are, someone is raising a hand, Mrityunjay sir. Yeah, you can go ahead.
I guess, Vinay, what you can do now, you can keep questions at the end so that your flow will not disturb.
Yeah. So I'll give the time at the end. You will be able to ask your questions. You can jot it down. So I'll continue with the next thing. So what are the main healthcare analytic techniques which are there? So I listed three things here. One is descriptive analytics, other one is predictive analytics, and the third one is prescriptive analytics. Coming to the first one, which is descriptive analytics, this provides insights as to the event which has happened. For example, a historical event might have occurred. So we'll be summarizing the event which has happened. The summarization can be done in terms of various techniques, which can be through either charts like univariate and multivariate charts, or it can be through tables wherein we can use descriptive statistics or inferential statistics in order to summarize whatever the event which has happened. So example of this includes tracking the patient admission rates over time. For example, we'll be able to sort of analyze what are the average number of patients who are visiting a specific department at a hospital, or what are the total count of number of people who are sort of visiting the hospital. So those are all example of descriptive statistics. So coming to the next technique, once we have sort of analyzed what has happened, the next technique is called as predictive analytics, wherein we'll be predicting what would happen in the future based on our past trends which has happened. So predicting these outcomes will help us to take actions. So example of predictive analytics includes disease outbreak using epidemiological data, historical time series data can be taken in order to forecast what would happen in the future. So in the first one, we are analyzing what has happened. In the next one, we are analyzing what would happen in the future. So once we are done with our predictive analytics, next analytic technique which can be used is called as prescriptive analytics. This goes one step further. Not only we are predicting what would happen in the future, we are taking the optimal decision or giving the optimal inputs to the model so that we'll be able to maximize our desired result. For example, once we have sort of identified how many patients would come to a hospital, we will sort of use that data in order to optimally allocate how much staff is required at a specific health institution. So these are the three main types of analytics. First one is descriptive, next one is predictive, and last one is prescriptive analytics. So once we are done with the three techniques of analytics in the previous slide, next thing is multimodal healthcare analytics. So what is multimodal healthcare analytics? In a healthcare scenario, the data is not resident at a single source. The data will be coming from multiple sources. And once we analyze this data coming from multiple sources, our analysis, whatever we'll be doing, it will be more accurate and more precise. So what are the various healthcare data sources or modalities which are there? There will be clinical text data or medical image data, or it can be time series data, genomics data, or it can be structured data like electronic health records, or it can be audio data and video data. So in clinical data, it can be in terms of PDF or text documents like doctor notes, discharge summaries, prescriptions given by doctors, or in medical images, it can be X-rays, MRIs, CT scans, ultrasounds, or it can be time series data like ECG data or heart rate data, BP levels or glucose levels monitored on a continuous basis, or genomics data like DNA sequence data. And then it can also be like structured data like electronic health records, or it can be audio data wherein patient-doctor conversations can be recorded, or it can be sort of video data can also be sort of one of the modality wherein surgical procedures can be recorded. So what is multimodal healthcare analytics? We'll see the definition. It refers to the process of integrating and analyzing multiple types of data such as text, image, signals, genomics, and EHRs to gain deeper and more holistic insights into the patient or clinical outcomes and healthcare systems. So we are not only analyzing one source of data, which is a unimodal source, we are integrating multiple sources of patient data and then providing the analytics. So coming to the next topic, which is what is prompt engineering and what is a prompt? So let us see that. So a prompt is an input or an instruction which is given to an AI model or a language model in order to obtain the response. So it's an input which we give, for example, for ChatGPT, we'll be giving the instructions as in what it should do. That's what is called as a prompt. So coming to what is prompt engineering, it involves crafting these inputs which guides the AI models or the NLP models in order to obtain the desired outputs. So if we give different inputs, the AI models will generate different outputs. But which is the most optimal input which we can give in order to obtain the most sort of desired output? So that is what is the basic aim of prompt engineering. So it plays important role due to the following factors. Efficient prompt design can help us in reducing the ambiguity or the complexity of the model outputs, as well as the computation overhead, as in the cost involved in this prompt engineering can be reduced, wherein we'll be using the less resources and cost could also be less. And it's also critical in application where the precision and accuracy of information is of utmost importance. For example, in healthcare scenario, the accuracy and specificity and sensitivity of the model or the analysis plays a huge role. So it's critical that we give the input instructions in a proper way so that we'll obtain the optimal outputs. So next, coming to the history of evolution of prompt engineering, initially around 1950 and 60s, there used to be rule-based system wherein specific rules were there, which was defined by the domain expert, so that if you give specific inputs, what would be the output? For example, if you design a chatbot, if you would have defined like if the input is this, the output is this. So those are hard-coded rules which used to be there in the initial systems, which was taking a lot of time as well as effort in order to build those rules. And if you have to replicate it for a different domain, it used to take a lot of effort. So these were the disadvantages of initial rule-based systems which was there. Post that, there was an emergence of machine learning models. So around 1980s and 1990s, there was this what was called as ML models, which was capable of taking an input and output, and it used to map or learn the algorithm of mapping between the input and output on its own. So that's what is called as supervised learning, wherein if you give an input and output, the model on its own, without the domain expert, learns the rules. But the challenges of these ML models was that it was not able to process sequential data, and also these were not efficient when the data set sizes were huge. So after that, we saw what were called as development of NLP model phase, wherein early 2000s and 1990s, we saw the evolution or computation power increasing, as well as the advent of internet started evolving, wherein huge data sets was available, and also there were distributed computing which was available, wherein the data was residing at multiple locations and we were able to process huge sets of data. Because of this, we were able to build sequential models which was capable of taking text data and analyzing and giving the output. So the disadvantages of the models which was built around 2000s and 2010s was that it was not able to give weighted input of each of the words in the sequence. For example, it's able to take the sequential data, only the last word in the sentence, it used to give higher priority in order to predict the next sentence. So because of the disadvantage, during the early 2015s as well as for the past decade, we have seen what is called as transformer-based models, which take input text and gives weightages for each of the words in the sentence. For example, if a sentence is there, it gives the important words higher weightage in order to determine the context or the vector for a sentence, and it gives lower importance to the words which are sort of least priority. So coming to the technical foundations which are sort of important for prompt engineering, there are two things which I've listed. One is NLP, natural language processing. Other one is large language models, also called as LLMs, which are sort of famous these days. So coming to the first technical foundation, it's NLP. It's the branch of AI which deals with the interaction between computers and humans through our natural language. For example, if we are able to give our inputs or instructions in our natural language, it can be English or a local language, then the computer is able to process what is the context that we are trying to tell from that sentence, and it gives the desired response for that output. This is possible through what is called as natural language processing algorithms. So the ultimate objective of NLP is to read the data which we are being given and decipher the data, understand what is the data that we are giving, and make sense of how humans would process it. Major applications of NLP includes machine translation, wherein we'll be able to translate from one sentence to other sentence. For example, if you give an English sentence, you'll be able to translate it into a local language for communication, better communication, and higher reach. The next application is text summarization, wherein if there is huge documents of data which is there, and it's difficult for us to go through those documents, we'll be able to use NLP techniques for text summarization, wherein it summarizes the whole content in few words. Other one is sentiment analysis, wherein if there is customer feedback or any feedback which is given for a service provided, we'll be able to analyze that in order to tell whether the feedback is positive, negative, or neutral, so that we can improve our respective operations. Other one includes speech recognition. These are mainly available in voice-based bots, wherein they take the voice data. For example, Siri and Alexa are example of that, wherein they'll be able to process the voice data and give a response for that. Other one is text generation, wherein we can use NLP to generate the text. If we have data scarcity, we'll be able to use these LLM models or NLP models in order to generate the text in order to perform our analytics. So coming to the other foundation, it's called as LLMs. Large language models are type of AI models which use deep learning technique. Deep learning techniques are those which sort of mimic the human brain in order to take an input, and few computations happen within the hidden layers, and then we'll be able to obtain certain outputs. So these deep learning models are used to build large language models. They're trained on vast data sets in order to learn the language patterns. For example, how a subject comes, how an object comes, and how they should be arranged, as well as grammar of a sentence, wherein various parts of speech and all can be identified, and the context of the sentence, as in what each word or what each phrase is sort of meaning. These LLM models will be able to analyze. So how are these LLM models trained? They're given huge corpus of data, and we'll give a sentence and as the input, and the next sentence or the next word which comes after that sentence as the output. So these models will be able to predict if a given sentence A is given, it will be able to predict sentence B based on the probability of what comes after the input. So the architecture behind most modern LLMs include what is called a self-attention mechanism, which, as I said before, it weighs the importance of different words or phrases in the sequence. It might weigh which are the important words in the sentence and give higher weightage for those words, and give lower weightage to those words which are sort of not important in the sentence or not take those words into consideration. So LLMs are typically pre-trained on general tasks like predicting the next word, or it can be predicting the next sentence. And then they're fine-tuned for specific applications using smaller or targeted datasets. For example, we'll be able to use ChatGPT, which is trained on huge internet corpus, and we'll be able to add our additional healthcare datasets in order to fine-tune it to predict more accurately. Through this training, LLMs or large language models acquire the ability to understand the nuances of human language, which might include the grammar, or it might include the syntax or the order of words which it comes, and the semantics which tells the context of the word. General text that is similar to human written text can also be sort of possible to obtain, and it might also include various writing styles and creative forms can be obtained. So coming to the steps which are involved in prompt engineering. So the first step is to define the objective. Here, in defining our objective, there are two subtasks which are there. One is to understanding what is the goal of our analysis, or what is the goal that we are trying to achieve. Other one is requirement gathering. In understanding the goal substep, we'll clearly define what the AI wants to achieve from the prompt. It can be either it needs to generate a text, or it needs to augment some text which is already there, or it needs to classify the information, or it needs to answer the questions based on whatever we are asking. So once we have sort of identified what is our goal that we are trying to obtain, next step would be to do the requirement gathering. In this step, we'll identify the specific needs as well as constraints of our application, such as it might be that we need what is our accuracy that we are trying to obtain, or what is the response time that we are trying to obtain, as well as the complexity of the expected output. So once we have defined our objective, next step would be to gather and analyze the training data if applicable. So for few prompt engineering tasks like data analysis tasks and all, we might need the relevant data sets to train the AI model or the LLM model on. So that once we sort of pre-train these models, they'll be able to predict in a better manner compared to the initial model which is there. So this data should be aligned with the desired outcome. For example, for sentiment analysis, we'll be able to give few data points wherein customer feedback is there, as well as the positive or negative label is there. So additional to the LLM model, which is already there, we'll also give the training data to perform better, or we are fine tuning it. So once we are trained it, next step will be to design the initial prompts. So in this step, we'll craft the initial version of prompts based on the defined objectives as well as requirements. So once we have sort of designed our prompt, next step would be to test and evaluate. Here, we'll give various questions to the prompt and obtain the answers from that. Here, we'll be able to see how various models perform. For example, Google might give one LLM, ChatGPT might give one LLM. We might test various LLM models by providing our prompts, and we'll be able to obtain the model. So once we have sort of obtained the model from various LLMs which are there, we'll be able to do the performance evaluation. In this step, we'll assess the effectiveness of the prompt through various metrics, which might include accuracy as well as the relevance to whatever we are trying to solve, as well as the user satisfaction. So once we've sort of tested our model, next step would be to optimize. Here we'll be fine-tuning the prompts or the instructions which we are giving in order to increase our performance or the specificity and sensitivity of our model. So once we have sort of fine-tuned our model, next step is scalability and generalization. In this step, we'll ensure that the prompt performs well across various settings as well as data points, wherein we can give various sort of cases which are not there in the training data in order to check how our data is performing on the test data, which is not in the controlled test environments. Once we are done with the optimization step, last step would be to roll the model or deploy the model so that we'll be able to test it with the user feedback. For example, in ChatGPT, you might have seen which response do you prefer. That is the iterative improvement phase, wherein we'll take the feedback from the customer or ratings from the customer, and those ratings will be used to improve the performance of our LLM model. So these are the six steps which are involved in building a prompt engineering model. So coming to the next topic, which includes what are the elements of prompts, or what are the anatomy, or what does prompts contain. So there are 6 main things which are there. One is the instruction, other one is context, next one is input data, next one is exemplar, the fifth one is output data, and last one is story. Coming to the first component, which is instruction. This is the core directive or the basic input that we are giving to the prompt, or what task it should perform. For example, write a poem or perform certain analysis, or it can be open-ended question like explain certain concept. So these are the inputs which are given to the prompt, or the instruction as in what it should perform. So once we are done with that, next step is context. So in context component, we'll be providing the relevant background information or historical information, or setting the scene for the LLM so that it understand what is the scenario on which it should perform certain instruction and tailor the response accordingly. So once we have sort of given the context on which it should sort of analyze the instruction, next is the input data. For example, if there is some starting text or an image which we are sort of giving, or some audio or video file that we have to add for analytics, we'll be able to add that input data so that we'll be able to perform our analytics. Once we have sort of given our input data, next step is we'll be giving an exemplar. So what is an exemplar? These are a few examples which can be given, like how the prompt should sort of give the output, or what the prompt should do. For example, we can give a huge sort of 3 paragraphs of sentence, and if you have to restrict that to sort of few lines, we'll be able to give that example, and based on that example, the model learns that this is what it should do next. So this is mainly helpful in what is called as few shot prompting. We'll check what is few shot prompting in the upcoming slides. So once we have sort of given an example as in how an LLM should sort of give the output, next step is output data. So we'll specify the format or style you want. Sir, sorry, sir.
ऑपरेशन में वाईफाई चल रहा है सही से क्वालिटी
Sir, your voice was actually breaking. Can you sort of repeat?
ठीक है क्योंकि जो सर आप रिक्वेस्ट करता हूं आपको
Can you put it on mute? Can you put it on chat instead of, because your voice is breaking?
Sir, can you put your question in chat? I am not able to hear. Your audio is breaking.
हमारी स्पीड तो अच्छी होती है
Host, you'll have to please mute all. Can
Yeah,
you do
yeah,
that?
mute. Yeah. Sir, you can ask your questions at the end. Thank you. I'll continue. You can keep your question and ask your question at the end. So coming to the output data, we can specify the format or style you want the output to be in. For example, if we need a PPT for the LLM to generate, we'll be able to provide that. Give a PPT from our instruction that we have given. Or if you have to generate a Word document, you'll be able to give the output in Word document, or in whatever format you require, you'll be able to provide to the LLM model. So the last element is tone. This indicates the desired emotion tone of the output. So for example, do you want the LLM to be, it needs to give an informative content or perceived content or humorous content or something else. So this also you will be able to specify, as well as the other element is called as role, wherein we will be able to tell for what person are we addressing the content also we'll be able to give. So coming to the next topic, which is what are the basic prompt structures which are there? So there are two types of prompt structures which are there mainly. One is called as close prompt, other one is called as prefix prompt. So let us check an example of what is close prompt and prefix prompt before going to a definition. So example of close prompt will include the capital of Francis, and you'll give a blank and close the sentence. The AI will fill that with the appropriate content. So what are close prompts? These are fill in the blank prompts wherein AI is expected to supply a missing word or a phrase. So we'll sort of restrict it to generate the specific content. The structure typically involves a sentence with a blank as denoted in the example. So the second type of prompt structure is called as prefix prompt. In prefix prompt, we'll be providing the beginning of the sentence or a paragraph and ask the AI to sort of complete it. So this is sort of open-ended question. The first one is sort of close-ended question. The second one is sort of open-ended question, wherein we'll give a sentence, and if we ask to generate a paragraph, it will give the content on its own with the freedom. There will be no restriction on what is generating. So these are the two types of prompt structures which is there. One is close prompt, other one is prefix prompt. So coming to the type of prompts which are there based on the who creates the prompt, there are two types of prompts which are there. One is called as manual prompt, other one is called as automated prompt. Manual prompt, as you can see, is crafted by human experts, whereas automated prompts would be generated by algorithms. So for example, when we give prompts to this ChatGPT, it's an example of manual prompts, wherein if we sort of, there is sort of some backend LLM, where there's an LLM application, and it's sort of able to take the steps on its own, whatever it should do, without sort of human inputs or human expertise, then that's an example of automated prompt. So coming to the definition, the manual prompts, these prompts are created by individuals who have deep understanding of AI model as well as its application context. So they require human intuition as well as creativity. So here domain experts plays a huge role in manual prompts. Other one is automated prompts. These are, as I said, mainly generated through algorithms. These are created using algorithms that can analyze large data sets in order to give the prompts that are likely to give a desired outcome. So let us check what are the types of manual prompts as well as automated prompts in the upcoming slides. So coming to the first one, which is manual prompts, as you have seen before, these are created by human experts who meticulously craft the instructions in order to guide the AI models what it should do step by step. These prompts are designed to be very specific about what type of data the model should focus on and what approach it should take and what output it should give. So there are two types of manual prompts which are there mainly. One is called as zero-shot prompt, other one is called as few-shot prompts. So zero-shot prompts are those wherein we'll not give any example as in how we should obtain an output. Few-shot prompts are those wherein we'll give a specific example and the model will sort of use that in order to predict the outcome in the specific format as in the example we have given. So these are often used in scenarios where nuanced understanding or particular approach is necessary. Wherein if we have some specific necessity, where there is a necessity of the domain expert to be there, then we'll be using what is called as manual prompts, wherein he'll be guiding step by step what should happen in each step. So example of this includes a researcher asking AI to analyze the specific trends in climate data, might use manual prompts like identify the correlation between carbon emission as well as average global temperature increase from 1990 to 2020. So coming to the first one in manual prompts, which is zero-shot prompts. Zero-shot prompts require AI to perform tasks or answer questions without any prior information or examples giving on the training data. So we'll not provide any examples or prior experiences for the model. The model itself, based on its knowledge or pre-existing information, it will generalize what should be the output. So what are the characteristics of zero-shot prompts? No task-specific training data is used. We'll not give any examples. It relies on the AI's ability to infer and generalize from the knowledge it already has or the pre-built knowledge which already exists in it. Example of this includes asking the AI model what is the environmental impacts of deforestation without having previously trained on environmental issues. So coming to the next type of manual prompts, it is called as few-shot prompts. In few-shot prompts, we'll provide the AI or the LLM with a small number of example or shots before requesting it to perform a similar task. These examples will serve as a guide to help the AI understand what is the context as well as the expectations that the user has from the model. So characteristics of this few-shot prompts include uses a limited number of training examples to guide the model. For example, we might give 3 examples of how the input and output should be and ask the output for the 4th example or the 4th input data. So this balances between zero shots, broad generalization wherein there was no example before, and using the full training data in order to predict what is the outcome. So example of this includes giving an AI model 3 examples of summarizing short stories and then asking it to summarize a new story. So we'll give 3 stories as well as give 3 summaries, and we'll give the 4th story. The model based on these 3 prior stories will be able to predict what is the summary for the 4th story. So coming to the next type, manual prompts had 2 types as we saw, zero-shot prompts as well as few-shot prompts. Coming to the second type, which I told before, that is automated prompts. Automated prompts are generated by systems or algorithms without direct intervention from the human each time they're used. This can be sort of based on templates or dynamically constructed by AI based on the context. So the agents which are there currently, which are sort of trending right now, are automated prompts, which sort of take the steps directly. Once we give the instruction, all the internal steps which should happen are done on its own, or all the in-between prompts are generated by the AI itself instead of human giving it at the each step. Only the final outcome is given to the user. So there are 2 types of automated prompts which are there. One is discrete prompts and other one is continuous prompts. So characteristics of automated prompts include they're scalable and efficient, particularly useful for handling large volume of interactions, wherein if the AI should perform large number of steps and there is no domain expert to give, then we'll be able to sort of scale it and perform the analysis in an efficient manner. It might lack the nuances and specificity of manually crafted prompts or the domain knowledge of the expertise which is available in case of manual prompts is not there here. And they're also faster and more cost effective in large scale applications. Example of this includes an AI customer service chatbot uses automated prompts to initially guide the conversation with customers. For example, we might be chatting with Amazon bot or a HDFC bot. Then it's example of automated prompts bot, which takes the steps on its own without sort of human intervention. So coming to what are the applications of prompt engineering. So prompt engineering enables language models to achieve wide range of applications in medical field with high performance. We'll check regarding 5 application use cases. So with customized medical prompts, models can accomplish complex healthcare problems that were previously difficult, as in it was taking a lot of effort and it required a lot of data sets also in order to analyze. This is sort of simplified with the usage of prompt engineering. So the 5 applications which I've stated for prompt engineering includes classification, generation, detection, augmentation, as well as question answering. So we'll go through each one of them in the upcoming slides. So coming to the first application, which is classification. So machine learning models, which are trained on labeled data sets, are called as classification models, wherein the model learns to identify the pattern between independent features as well as dependent features. The dependent features will be categorical in nature. The independent features will be the input data, or the sort of, it can be both categorical and numerical. So once we sort of give the dependent and independent features to the model learns what is the mapping, so that if you give new unseen data, the model will be able to predict what would be the outcome, or what will be the class of the input data. So example for this includes, for example, if we are sort of having the input features of the person and we are trying to predict whether he is likely to have diabetes or not, or likely to have heart attack risk or not, or if, for example, if we give the image data and we are trying to classify whether that person is having cancer or not. So those are sort of application of classification models, wherein we train the model with input features of a person, and we are able to predict his sort of likelihood to sort of get certain disease, or also used for diagnosis. So in this classification, the model analyzes the feature of new data and predicts the classification based on what it has learned from the training data. So we'll see three applications of how prompt engineering is used for classification models. The first one is medical image analysis. Researchers have built what is called as GPT-4 which incorporates generative pre-trained transformer models for medical image analysis. For example, you can see at the end I've given an example, which is sort of, the prompt is this way. A radiologist uses a prompt like identify and measure any pulmonary nodules present in the following CT scan, considering the patient history of smoking. So not only are we giving the CT scan of the person, we are also giving the patient history, which is a text data, as well as we can give other sort of features of the person in order to predict this likelihood of getting certain disease. So GPT-4 is a specialized version of generative pre-trained transformer, which can sort of process medical images as well as text data. So previously I told what is multimodal sort of image analysis or multimodal healthcare analytics, wherein we use image as well as it can use text data as well as audio data, or like Excel or EHR data can be used in order to determine certain outcome. So what is the purpose of this model? It was developed to enhance the accuracy, efficiency, as well as specificity in diagnosing medical image. Sort of, it can be in terms of X-ray, MRI, or CT scans. So coming to the next application wherein prompt engineering can be used for classification techniques, it includes clinical text classification. Health prompt is an example of that. For example, if we take a sentence like, the patient has cough and expanded chest that does not deflate when he exhales, the symptom is for what disorder? So the model will sort of, LLM will be given the symptoms of the patient. It will be able to predict what is the disorder that the person is facing. So this is an example of classification wherein given an input text, it is able to, given the symptoms input data, it's able to predict what would be the outcome. So the key feature of health prompt NLP model is that it does not require any training data. We can sort of directly feed the unlabeled EHR corpus to the framework after defining the prompt template. So whatever we have given is a prompt, whatever I have written in the example is a prompt template wherein we have given the input as well as we are giving what is the expected output or what the model is supposed to do. So the purpose of this model was to classify clinical text using predefined language models without the need for training data. So coming to the other application of classification techniques for using prompt engineering, it is mental health classification can be done. Researchers have used ChatGPT model in order to do language-based model tool for mental health classification. So the purpose of this model was to classify the social media posts for stress detection as well as depression detection as well as suicidal detection. So this model demonstrated strong capability in classifying without prior specific training, or this is an example of zero-shot learning wherein the LLM was used to classify the social media posts or Twitter data for stress detection as well as depression detection. Example of this is for the stress or non-stress detection tasks, what is the prompt that we need to give? Which of the following classes can the post be assigned? Only reply with the answers of one of the class. So we are telling what should be the outcome. Either it should be stressed or non-stressed, as well as we are adding the post before this. So once we sort of give the post as well as the classes that we are sort of trying to identify, the LLM model will predict whether the person is stressed or non-stressed or sort of having any other issues. So coming to the next example where prompt engineering can be used, it has a lot of usability in sort of data generation. wherever there is sort of data scarcity or data is not available and we have few data samples, we will be able to sort of generate new data points which follows the distribution of the already data points which are there. For example, if we might have 30 rows of patient information or patient fields or records which are there, we'll be able to increase the sample size based on using the LLMs, which sort of gives the data which will have the same distribution as the initial distribution which was there. So prompts can act as instructions for AI models, guiding them to generate new data points. We can also specify the desired format. For example, we'll be able to tell give me in PDF or give me in Excel or give me in text format. So whichever format we need the data to come, we'll be able to generate that, as well as we'll be able to specify what type of data, whether it's a numerical data or categorical data, and what should be the values of the data that we are trying to generate is also possible. So this allows us to create data sets which closely resemble the real world data for training as well as testing purposes. AI models can use prompts to generate synthetic data sets for training. So we can also use, for example, if we have some data set which is already present in open source data points like Kaggle and all, we'll be able to upload that and generate huge sets of data based on the distribution which is already there, which replicates the real world data, but it's a synthetic generative data. So coming to the application wherein researchers have used data generation techniques, the first one is medical text generation. We are able to see that on the right side, there is a complex medical abstract which is there, which has multiple steps of clinical trials that it has identified. The LLM is able to identify the keywords in that in each of the sentences which are there, and it's able to summarize in plain language summary. So we are able to see it has once it identifies the keywords, those keywords will be used in the next step in order to generate new sentences which are given in the below in plain language summary. So coming to what model researchers have built, NAPSS introduced the technique of summarize and then simplify. We are able to summarize what are the keywords in the large corpus which is there and then simplify the contents which are there. So what is the purpose of this model? It generates summaries to train the model to extract the key contents. Also, it uses narrative prompts to guide other generators to clarify the text while maintaining the flow. So if there is huge corpus of text, we might have multiple research papers which are there. So we'll be able to upload those research papers to language models and it will be able to obtain the keywords or it will be able to summarize it in fewer words. So other application of generation for that researchers have built include medical report translation. People have evaluated ChatGPT for translating radiology reports into plain language for educational purposes. For example, to generate both general and specific recommendations based on the reports which are there for various levels of audience. So if we have certain document and if we have to summarize that for an undergraduate education person, or if we have to summarize that for a postgraduate education person, or if for a college student, or for sort of some other person who is sort of layman, then AI is capable of generating it for specific roles of people, specific content, so that it will be most optimal for them to understand the content which is coming. So coming to the third application, which is detection, prompt engineering detection helps it sort of identifying specific entities or anomalies or conditions within medical data, such as images, videos, as well as text documents. So given an image, it will be able to detect specific, if there are any diseases are there, or given a text document, it will be able to identify specific keywords or medical terminologies which are there in the content. So we'll see one of the application wherein sort of we'll be able to give the patient details or patient sort of notes, and we'll be able to sort of de-identify certain records so that privacy of the patient data is protected. So this application guides AI models to focus on analytics of particular areas or features that are clinically relevant, thereby it aids in diagnostic process. So what are the benefits of medical detection analysis? It's sort of useful for improving the accuracy and earlier detection of disease, thereby preventing the progression of certain diseases. It can also reduce the workload for radiologists and other medical professionals because it's able to identify what is sort of might be missed by a radiologist. And it also has the potential for personalized medicine applications. So coming to the various applications of detections, the researchers have built what is called as DID-GPT, de-identified GPT, it's also called, which uses GPT-4 to de-identify the medical data, ensuring that privacy is preserved while preserving also the meaning. For example, I put in the text box one of the example content, wherein the original medical text was patient John Smith, a 42-year-old male with history of hypertension, was admitted to emergency department and he was experiencing whatever the symptoms is given and his vitals are given. So the DEED GPT output was able to identify that John Smith was the name of the person, and in the output it's able to de-identify that and give it as ID. So in the output you'll be able to see instead of John Smith name, the output is input is sort of de-identified and it's generated a sort of unique ID wherein the patient privacy is sort of protected. So coming to the next technique, it's called as data augmentation. It involves artificially expanding the available data sets by generating the new data points, which is sort of voluminous. And benefits of augmentation prompts include it enhances the model training by augmenting the data sets with generated samples. The classifier models can train on wide range of scenarios, potentially increasing their accuracy. It will also help in sort of reducing overfitting, wherein it is able to generalize rather than sort of tuning or training the model on specific data points, and it's also cost effective. So coming to the various applications wherein text augmentation can be used, chat.org is what is built by researchers, which is sort of able to do the text augmentation that utilizes ChatGPT in order to rephrase the content. For example, I have given in the table, the follow-up rate after 5 years was 85% is the original text which was there. There are 6 alternate texts which are generated, which sort of follows the similar pattern. The study showed a follow-up of 85% after 5 years is one of the content. The 5-year follow-up rate was found to be significantly high at 85%. So we are sort of rephrasing the sentences in the training data in order to create multiple conceptually similar or semantically sort of different samples. So there are different sort of words, but they all have the same meaning or same sort of conceptual idea. So this can be sort of used to enlarge the sample corpus for training purpose so that we can reduce the overfitting as well as increase the model accuracy. So coming to the next application or the last application is question answering. This application is designed to post questions so that the AI models search, comprehend, and accurately respond based on the medical knowledge base which is there. So there will be knowledge base which is there, and the models will be trained on this knowledge base, and we'll be able to question this AI model so that it returns the values based on the knowledge base. So we'll be seeing what is called as notebook LM, which sort of takes links or website links or PDFs as inputs, and based on the PDF content or the website content, it will be able to return the questions whatever we ask to the model. So these models need to ensure that AI systems are not only technically proficient, but are also reliable in providing the correct as well as relevant medical information. So coming to the various applications of question answering which researchers have used. So it's mainly used in medical image-based Q&A. So what is this model? The tokenized visual data as well as processed questions are combined to form a prompt. This is sort of multi-modal example. For example, we'll be giving the image data as well as the question to the prompt as in text data so that the prompt will be able to respond with an answer. So the purpose of this PLMs or pre-trained language models is to understand the medical image from open-ended visual question answer tasks where answers are not only limited to the predefined options. So we are able to see that X-ray of a knee is given. Along with that, the question is given asking what is the abnormalities which is present in the knee. So the model will be able to answer that there is a fracture in the left radius head. This will sort of help the radiologist in the detection purpose. So coming to other application where Q&A can be sort of used. So it's medical video-based Q&A wherein we'll be able to sort of using text, we'll be able to sort of generate video contents, and we'll also be able to using video, we'll be able to query what is present in that video or based on the contents which are present in that video. So researchers have built what is called as VPTSL, Visual Prompt Text Span Localization. As in, if you give a text, it will sort of generate various text spans or text images, and those text images will be sort of merged so that videos will be sort of generated based on the input prompt which we have given. So the purpose of this was to demonstrate the effectiveness of visual prompts and text span predictor for medical video Q&A. For example, user has given how to examine lymph nodes in head and neck. And if we ask it to generate a video for that, the model will be able to generate a sample video based on the text so that we'll be able to see how it's be sort of able to examine the lymph nodes which are present in head and neck. So coming to the various tools which can be used for prompt engineering, it includes prompt base, prompt layer, and LangChain can be used, ChatGPT and OpenPrompt. Few of them are listed, there are many more. So coming to the first one, which is prompt-based, this is a marketplace for AI prompts that facilitates buying as well as selling of prompts, wherein sort of various models like ChatGPT, DALL-E, as well as the other GPT models which are there. These models would be there, and we'll be able to buy, which is sort of an optimal prompt for analysis, and we'll be able to sell our prompts also if we design it. So other one includes prompt layer, wherein we'll be able to track and version and compare various prompts. For example, we'll be able to give our inputs to two different prompts. We might give it to ChatGPT, as well as we might give to Gemini, which is built by Google. And we'll be able to track how the output quality is from each of the models, and we'll be able to sort of version it and compare which is sort of costing us less, which is sort of more accurate in order to select the optimal one. Other one is LangChain. This is sort of has what is called as LLM. We'll be able to build LLM chains as well as agents, wherein we'll be able to give a prompt template and the model, whichever we are sort of needing for analysis. All the things can be defined so that the whole analysis chain of steps can be followed for the analytics can be defined. Other one is ChatGPT. This is sort of more famous. This is a conversational AI bot which is developed by OpenAI. It helps to sort of interacting in multi-modal ways. We'll be seeing how we can sort of upload today to a ChatGPT account with multi-modal data, including PDF data, as well as Excel data, and sort of integrating those data points to sort of analyze what would be the outcome or what is the analysis that we're trying to perform. We'll be doing it on multi-modal data points using ChatGPT. Other one is OpenPrompt. This is sort of an open source framework for prompt learning, which sort of helps us in deploying prompt learning pipelines. For example, if we need to run these prompts on a periodic basis, then we'll be able to use what is called as OpenPrompt, so that the prompt pipelines can be built, which sort of runs on a scheduled manner on its own without sort of human trigger, and it will be able to generate outcomes on a time period basis. So coming to what are the challenges which are involved in prompt engineering, the first one is ambiguity and misinterpretation. It's the challenge is that it's difficult in ensuring that AI understands the complex prompts. So if you are sort of not able to give the prompt in the proper manner, it sort of misinterprets that, and the output is sort of not whatever we sort of desired to obtain. Other one is prompt sensitivity. Minor changes in wording or rephrasing of sentences might lead to major changes in sort of the result the prompt gives. That's also a challenge. Other one is ethical consideration. We have to design our prompts which align with sort of ethical guidelines so that it will not produce something which is sort of unethical content, so that we have to test that before sort of rolling our model, so that it is sort of giving ethical contents, and in edge cases when we are giving, it's not giving something which is not ethical. Other one is bias and fairness. We have to mitigate the inherent biases which are there in the AI responses. So if while testing our prompt before sort of deploying it, if we are sort of identifying that it's providing biased content towards certain sort of gender or sort of certain creed or some caste or something, then we sort of identify that and give it lower sort of score or lower rank, so that it sort of does not replicate those results in the real environment or the real world data. Last one is model limitations, working within the constraints of AI capabilities. So we should also this is also a challenge. Few of the LLM models will not be able to perform certain tasks. So if it's trained on specific knowledge, it will be able to perform only on that specific knowledge and not on sort of new domain certain types. So we should be aware what is the training data which was used for that model, and what is the scope of that, and what are the limitations of the model. So this is regarding the brief theoretical knowledge which I have to give regarding prompt engineering. Initially we learned regarding what is the sort of healthcare analytics, what is type of analytics, what is prompt engineering, what are its foundational things which are used, what are the types of prompt engineering, as well as what are the applications wherein it's used in healthcare scenario. And last one was regarding the challenges which are there. Next, I have sort of 3 quiz questions which are there, which you can answer in the chat. Whoever is sort of able to answer that faster will be sort of getting a gift from our end, or sort of a prize from our end. So if anybody has questions, you can sort of ask that. After that, we'll be going to the quiz questions next. After the quiz questions, we have the practical implementation, wherein we'll be using ChatGPT to sort of use a multimodal analytical model, or build a multimodal analytical model, wherein I'll be giving a PDF data which has text corpus, as well as I'll be giving CSV data or sort of Excel data, tabular data, in order to perform certain descriptive analytics using ChatGPT. So if you have any questions, you can sort of ask them.
Hi. I
Hi.
had posted a couple of questions. Sorry, I'm not able to switch on my camera. I'm in the low data place today.
Okay, no issues.
I'm Dr. Aman Kapoor here.
Yeah.
Couple of questions. First of all, thank you for sharing this information. And
Yes.
few things that I would like to ask you. See, a lot of healthcare organizations, we see that the data is quite unstructured.
Yes,
So,
sir.
let's take an example of an organization that I know which has got multiple hospitals and clinic chains. They have silos of data. One is sitting with the CRM, some data is sitting with their on their Google Sheet, some data is in the form of PDFs or images or audio files. There is a EHR data, there is logistics data. So data is so spread out. It's more like a data lake kind of thing. So how do we address this situation? One. So that's the first question that I would like to ask.
So regarding that, actually, we will be, if we are sort of storing it somewhere in a data lake or something, and if we are able to provide, like sort of create an API through which we'll be able to access this data, or if we are able to feed into the AI model, the model is sort of capable of handling this unstructured data and obtaining the information from that. For example, in the PDF, there will be no structure, or in the image, there won't be any structure. So the model is sort of able to identify on its own, because it's trained on huge corpus of unstructured data. It will be able to identify what are the key things that it has to fetch from that. So that's how these LLM models are trained. For example, I'll also showcase to you, if you need, there is a prescription notes that I've downloaded, which sort of has unstructured data, and it is able to fetch from that, which are sort of required data points from that based on the prompts which you give. Or these are also sort of addressed to what is called as agents which they are building, wherein instead of a human input which is given at each step to handle the unstructured data, AI automatically sort of identify what prompts should I give next to in order to obtain certain outcome. But it's a challenge itself. If it's not able to sort of pre-process this unstructured data in a accurate manner, then that is sort of a challenge itself, sir, and it's still in training phase, I would tell.
Okay. Thank you so much. And the other question I had is that, see, my first interaction with AI was in 2008, when we were using neural network imaging for pre-cancer diagnosis. So, of course, at that point of time, the software didn't do the diagnosis, but it just pointed out to the most, abnormal areas and gave the X and Y coordinates of the pathologists who could then check and come to a conclusion that, okay, this particular case is at what stage of pre-cancer. Now, in today's time, with the advent of, with the rapid change of AI-based structures and technologies, is this relevant in today's date, or it's kind of outdated? The neural network imaging concept.
So that is sort of the base for what is this language models actually which are there. So these are sort of built based on that. So the transformers are the prerequisite for large language models, which are sort of encoder and decoder networks. So these internally use these neural networks itself. So there will be an input which is there, and there will be an output which is sort of is there as supervised label or labeled data set which is there. So based on this labeled data sets which are there, the model learns what is the mapping through neural networks itself. So these language models also internally use this neural networks only. So they are sort of the brain behind that, sir. That's what I would tell.
Oh, awesome, awesome. Thank you so much for simplifying this. Is there anywhere, I mean, one is, of course, the course is there. Is there any way we can connect? I would love to, I mean, I'm exploring a section of data, AI, and analytics, etc. So is there any collaborative model or somewhere we can connect with your team to discuss this further?
Yes, so we have a center called as ADMIRE. It's for like advancing the digital health research. So that was started 3 years back. So that's where our collaborations with digital health and AI companies work. So Dr. Akash is leading that. He'll be sort of connecting with you regarding that.
Perfect. Awesome. Awesome. Thank you so much. Thank you. Appreciate your guidance and thank you for answering.
Thank you, sir. So if anybody have questions, you can ask, or else we'll be able to go to the quiz questions, and you'll be able, you're required to answer in the chat. Whoever sort of answers first, as I said, will be getting sort of a reward from our end. So maybe we can sort of proceed, is it?
Hello, sir.
Yeah. Hi.
Yeah, good evening, sir. Thank you for the brief session. This is Dr. Karthik from Chennai.
Hi, Karthik.
Yeah. Yes, sir. Just I have one doubt about the data privacy while we are using the AI model, sir. If we don't have an AI model for our own system, we are going for a public AI model for statistics or any other thing for a research data. So if we are going to feed our research data to the AI model, will the model use the data for its own training, and will it be replicating the data results to the next person who is going to give a prompt based on the similar study?
This is sort of an issue, as I agreed you addressed the proper thing. Recently, what is trending is this Ghibli images. People are sort of putting a lot of their data, and we are able to see ChatGPT is also prompting, giving a response, a notification that this data might be used for training purpose and all. So it's always sort of better that we sort of see the analytics. If we sort of, I'll show an analytics which I'm doing with ChatGPT. It's better if I see what is the code behind that and what is the analytics that it's doing, rather than feeding the model, the data directly to the LLM models which are available. So, for example, now if I feed my Excel data to ChatGPT, it might use it for training. So it's better that we might ask it to generate the Python code which is used for that analysis, which it does in backend, and I'll show that how we'll be able to see that. And if we use that code for sort of analytics on our own, then it will be sort of helpful in cases where we need to protect our privacy.
Okay.
So yeah, that's all.
Thank you. Thank you for clearing that. Yeah, thank you.
So if you are done with the questions, we'll go to the quiz. After that, we have to also work with our practicals. So I'll sort of go to the quiz questions. There are 3 questions which are there, which are MCQ based. So you can answer the whatever is the option that you're selecting in the chat. So coming to the first question. So calculating the total and average patient load at a hospital belongs to what type of analysis? So if you are computing the total patient load at a hospital as well as average patient load at the hospital, is it descriptive, sentiment analysis, or predictive analytics, or prescriptive analytics? I see a lot of answers coming out very fast. So option A, that's correct. It belongs to descriptive analytics since we are summarizing what event has happened before. So maybe I'll go to the next question. So coming to the second question, which of the following is not typically considered a basic element of the prompt used in prompt engineering? The desired emotion tone of the output, whether it's informative, humorous, or persuasive. Starting text, images, or data points that serve as a foundation for the generation. How quickly the algorithm processes the prompt. Optional examples which are provided in few short prompting to guide the model response. So I'm able to see a lot of answers are coming as option C, and yeah, option C is correct. Option A is not correct because we might be able to give the emotional tone as an input to the prompt template so that we'll be able to obtain the content in the specific format. So option C is correct, wherein we need not tell how quickly the algorithm processes the prompt. That is not sort of a basic element of the prompt. So coming to the last question, which of the following is goal of prompt engineering? Reducing the computation power needed for simple tasks, ensuring that the prompt gives the desired response from the system, reducing the amount of data needed for processing, decreasing the time it takes to develop the algorithms. So most of you are correct. The answer is option B. The goal of prompt engineering is to mainly ensure, given the specific instructions, it's able to give the desired response from the system, which is optimal, whatever the user has asked. So we are done with our quiz questions. Now let us have slightly practical sessions for another next 10 minutes, wherein we'll sort of try to give multimodal data, PDF data, as well as CSV data for the AI model in order to give the ChatGPT LLM model in order to do basic descriptive statistics. You will be able to extend that to predictive as well as prescriptive analytics, but that requires slightly learning of the algorithms or the brain behind those analysis, whereas descriptive models are basic summarization. So we'll check how we'll be able to do that next. So I'll be going to the ChatGPT account which I have, and I'll be showing the input data which I'll be using for that. Let me go to the folder where the files are there. So these are the three files which is there. One is the prescription data of the person, which has patient ID, his diagnosis, as well as medication. Other one is lab test results. Other one is vital data of the patient. So this is having 41 patients data. So I'll open the first one, which is a PDF document. So here you'll be able to see this is prescription data of a care clinic and who is the doctor. What is the patient ID, diagnosis, as well as the prescription, whatever the medication which is given to them. So this is for one patient. There are 41 pages which are there. So I have concatenated all so that it is in a single PDF document so that I'll be able to upload to my language model. So you'll be able to see there are 41 pages wherein each page contains for one patient what is his ID as well as what is his diagnosis as well as the description of prescription whatever is given to him. So the other two data points which are there includes lab test results of the patient. So if we open this, so this contains the patient ID. You can see that there are 41 patients are there and their IDs are there, as well as the WBC count, white blood cells count, as well as the creatinine levels is there. So these are the two lab indicators which are there. I'll open the other file also, which is there. So this is the third file which is there, which has vitals data of the patient, which includes patient ID, his heart rate level, as well as his BP levels, which is both the systolic and diastolic BP levels. So all three data points are there for 41 patients. Now I'll be uploading these three files to ChatGPT and sort of doing basic descriptive statistics by integrating all these three models or all these three data sheets. So you will be aware where to sort of open or what is the website of ChatGPT. It's chatgpt.com. And since I have a premium account, I'll be having additional features to what you guys might have if you have the basic account. So this is the user interface wherein the previous chats you'll be able to see here. And there is an option to upload the data files, or you will be able to search from the internet or create image, and there are various other tags. This is for voice mode. You'll be able to interact with the LLM using voice data also, or conversational based. So I clicked on this plus. Now I'll be, since my data is in my local system, I'll click upload from computer. So I went to the folder where my data is there and I'm selecting the prescriptions data first. So the first step is I'll read this PDF data which is there. Then in the next step, I'll sort of read the Excel or CSV files data. So already I've added the prompt in order to read these things and perform the analytics so that it saves certain time. I've copied this. The first prompt is read the data of patient ID, diagnosis, and prescription given in the PDF into 3 columns. So I'll copy this prompt. I'll go here to ChatGPT. You can see that the file is uploaded here. I'll paste the prompt here. So we have our input and we have what is the prompt or the action it should perform. So next I'll click the upload button or the run button. So you're seeing that it's analyzing the data which is there. So if you click on this drop down, you'll be able to see the Python code which it generates. So this can be sort of used in other environments if you have to perform the analytics on your own. So once we have sort of read our data, next I'll show what are the steps that we'll be doing in terms of the descriptive analytics. by the time it sort of reads that PDF. First, I'll be reading the 3 data points which are there in the PDFs of prescription data. Next, I'll be reading the data in the 2 CSV files, which has patient vitals and then patient lab results. Next, I'll be merging all the 3 sheets based on the patient ID. So what is the common column or the common identifier in order to merge or integrate all these 3 sheets? It's the patient ID. So I'll be merging based on that patient ID. Next, I'm showing a filtering task wherein we'll be able to obtain the details of a specific patient with ID 4 and then filter only that person's detail. If we have to do, we'll be able to do a data transformation technique. So once we are done with that, we'll next check to obtain basic descriptive statistics and exploratory data analysis. For example, I'll obtain the mean of BP systolic column or median of all numerical columns I'm trying to obtain in the next one. Once that is done, I'll be obtaining the total number of people with each diagnosis. So there are various diagnoses. We'll check what are them and how many patients are there with respect to each diagnosis type. Once we are done with that, we'll try to plot a bar plot which contains the total number of patients for each type of diagnosis which we have got in the previous step. Once we are done with that, next step is we'll add labels to the data. That is like slight pre-processing or slight transformation of the plot which we obtained. Other one is like again the slight transformation or font change as well as color change of whatever the data graph which it has generated. And last step is I will be taking the chart, whatever I obtained, the bar chart which contains total number of people as well as the for each type of diagnosis in a PPT as the output. So I'll go back to ChatGPT now. Let me check if the first step is done. So you are able to see that it analyzed the PDF document and it's generated a structured form of the unstructured data which was there, wherein we have extracted the patient ID. It's there from 1 to 41, and the diagnosis of the patient is there, as in what is sort of diagnosed with, as well as the prescription details of that patient, whatever the medication he has to take, or the medication which has to be given to him is there. So once we sort of read our PDF data or the unstructured data, next I'll be uploading the 2 other structured data files which are there, which contains the vitals as well as the lab results data. So I'll select both of them and I'll click on open. So you'll be able to see both of the sheets uploaded fast. So generally structured data sort of uploads faster compared to the unstructured data since the file sizes would also be small. Next, once we have sort of uploaded our 2 CSV files, next step is I'll give the next prompt, which is to read the data in both the CSV files. We have read the PDF data. Next, we are reading the data in the CSV files. So once I give this prompt, we are able to see it read very fast. What is the lab results data consists of? All the 41 patient details is there, as well as what is the vitals data. So now, first we read our PDF, next we read our 2 Excel files. Now, what will be the next step? Next step would be to integrate all of these 3 data sets. So it's already giving, see, let me know if you would like to merge with the patient diagnosis and prescription data and analyze the prints. So I'll give my next prompt, which is to merge all the 3. So what is the common column or the common ID based on which I'm merging? It's the patient ID. So I'll go back to ChatGPT. I'll sort of give, can you merge all 3 data sheets based on patient ID column, which is the common ID. So we are able to see that it's analyzing. So if you click on this drop down, you'll be able to see the code content which it's generating. So if you have to analyze whether it gave the proper analysis or not, you should be aware of like Python here, so that we'll be able to validate whether the code, whatever it generated, is proper or the analysis, whatever it's doing, it's proper. So we are able to see it's merged the whole data. So there is patient ID, there is diagnosis, as well as prescription, which was in PDF. Along with that, we are able to join the WBC count of that patient, as well as creatinine, which was in lab test results of the patient, as well as the heart rate, BP levels, and BP diastolic and systolic, which are the vitals of that patient. So we are able to see we have integrated all the multimodal data sets, including our PDF, as well as structured files. So once we have integrated, let us go to the next step of basic descriptive analytics and basic data transformation. So this is an example of data transformation or data filtering, wherein I'm telling the AI model to sort of obtain the details of only patient 4. So if I go here and give this prompt, So we are able to see that it's analyzing. So we are able to see the details of patient 4R, what is his diagnosis, what is his prescription, what is his WBC count, his creatinine, as well as blood pressure. So it's also suggests. So it's also suggesting that whether it should do further analysis or visualization. So if you give it to do it on its own, it will be example of automatic prompts, automated prompts. Otherwise, if you sort of give it on your own, it will be an example of manual prompts wherein you are telling the specific steps it should follow. So if I give the next prompt, so I'm giving, can you obtain the mean of BP systolic column? So you are able to see the mean of the blood pressure column across all systolic column across all patients is 120.20. So this way you'll be able to do various descriptive statistics like obtain the median. Also, let me go to the next one, wherein we'll count the number of patients with each diagnosis. So here there was, if you see the data, there was patient ID as well as diagnosis. We are just aggregating or doing a pivot table so that we'll check across each diagnosis how many patients were there. If I scroll here, so you'll be able to see here are the total number of patients for each diagnosis. COPD has 6 patients, hyperlipidemia has 6 patients, anemia has 5 patients. That way, for each of the diagnosis categories, how many patients are there, we are able to obtain. So the last one, which we'll be sort of last two things which we'll be doing is we'll generate a bar plot. So already around 620. And the last one which we'll do is take the output into sort of a PPT. So I'm giving the prompt as, can you obtain the bar plot of the total number of people with each diagnosis? So if I go here and sort of paste that thing and run that. By the time it runs, let me copy the last one. Can you copy the chart data into a PPT? So you're able to see it generated a bar plot wherein the total patients is on y-axis as well as diagnosis on the x-axis. So you'll be able to add the labels, change the colors by giving prompts to this, and do other sort of transformations for these plots by directly giving prompts instead of doing any analysis or any sort of transformations. So the last step, I'm asking it, can you give the chart data in a PPT? So if I give this prompt, it will sort of put my chart data, which is there already in sort of an image format into a PPT, and sort of we'll be able to download that for sort of further usage or further analysis purpose or for describing to the end user. So before, it's giving the output. So it's telling your PowerPoint chart is ready. You'll be able to download it with the link. So if I click on this, and if I open this, so you will be able to see that the chart gets sort of added to the PPT automatically on its own. So that is regarding how ChatGPT can be used for multimodal analysis. I was planning to teach regarding 2 other things, including Google Colab, wherein you will be sort of whatever the Python code it has generated, you will be able to sort of run in an environment and check how each step works. You'll be able to do that with open source. Other one I was planning to teach is Google Notebook LM. Here, for example, this is the link for that notebooklm.google, and if you go to that link, you'll be able to sort of give certain sort of links, and based on those websites, you'll be able to query certain results. So if I, for example, if I click on add, I can add a link or a source or website from which we'll be able to query and sort of obtain certain sort of outputs. So someone is sort of messaging in chat. Yeah, a lot of LLMs generate the content. We used to sort of analyze at one end what is the accuracy and quality of those analytics in order to determine whom to trust or who is sort of most optimal for our use case. So we can use various sort of testing tools like A or B testing tools in order to determine which prompt has performed better. So this is the last one which I'll be showing today, wherein I'll be adding the link of our website wherein we have details regarding our AI and data science course here, which Akash sir was mentioning initially. And I'll go here, and if you click on the website and paste the URL, whichever we are trying to question or ask the questions regarding, and if I click on insert, so you will be able to add that, and you will be able to ask questions this way. So for example, I have asked questions like, how many terms are there in this course? It's able to answer. I have asked questions like, what does the first term of course contain? What is the specific subject? So if the contents are there, it will be able to answer. But if the contents are not there, it tells that, for example, I've asked what will be taught in the subject. It is telling that the provided source does not contain specific details regarding the curriculum or the topics which will be covered in that subject. So it's not answering out of the data which is there already in that website or the source whichever we have provided. So these are the three tools which I was planning to teach. I hope it was sort of helpful. The session from your end was also, there were a lot of learnings and you guys were responsive. I sort of thank all of you from my end to sort of keeping it as an interactive session by also giving your responses in chat. So over to you, ma'am. If you sort of have any sort of, you are telling that regarding we have to obtain the feedback from the users, you can sort of share that in the chat so that users will be able to give the feedback regarding how was the session.
Thank you, Vinay sir. We have shared the link for feedback in the chat box. Everybody can use the Google form link to share the feedback and avail the certificate. Thank you so much.
Thank you, Vinay. Thank you, Poonam. I hope that you guys were able to kind of, get a brief glance about how really these large language models are making our life easier to a sense. There is some kind of, I guess, what can I say, um, reducing human efforts that like if I were to do this with spaces of data, it would take maybe me 15 to 20 minutes for a standard time. But then and a lot of front and back in my system, I had to minimize, maximize few things, check the data and go back, and there are a lot of errors also to correct. But then the LLMs have this ability to do this in real time, and that's what I think we have been kind of looking at since the launch of ChatGPT and others. Overall, at this point, AI and large language models have kind of brought a lot of promising things. It's only that how we really want to use them for our benefit and kind of, try to make best out of it. The key thing is that they will eventually become a de facto tool for many of the things that we were using different software. So that's I think the key to learn. And finally, coming to the winner of the contest, I hope Poonam has gifted with her. So we have Nikhil Bhavsar. I think he has answered the fastest and he has answered, I think, the most questions in time. Congratulations, Nikhil. I think you can, uh, you know, uh, connect with our team and they will share with you how to get your gift. Thank you, everyone, and please fill the feedback form because that helps us to make it better for next time and also understand your suggestions and improve on the upcoming topic. Thank you, everyone, for joining. Thank you, Vinay, and yeah, have a
Thank
nice
you.
day.
Thank you. Everyone. Yes.